So along with this workshop, there is a presentation and a HackMD page. On this HackMD page, you can find links to useful information. Also later, if you want to learn more about the workshop, then there are some further readings. I will start sharing my screen. So now all of you guys should be able to see my screen. So here's the link to the HackMD page, and I will also put this in the chat. So now everybody should have it should be able to open it. And basically the goal of this workshop today is transforming a breadboard prototype to a printed circuit prototype. I also have a overhead camera. So if I get that one here as well, so you should now be able to see my hands and some printed circuit boards. Let me get a little bit more light in there and this wire out of the way. So basically the idea for today is that we have such a breadboard prototype where most of the time there's a lot more wires in between these jumper wires, and with that you have a electrical circuit and you can test your functionality. But if you want to make it a little bit more professional and more easy to replicate and make it sort of foolproof, then you can go to a next stage, which would be something more like a printed circuit board that you can, for example, see here. So this one, with this one, it's basically a flat version of the breadboard circuit. So all of the connection that you would otherwise make with the breadboard, you would then be able to have as a printed circuit board. Let me see if I can give a bit better overview so you can see both of them at the same time. And with this prototype that we're going to explain today, you still use the modules. So it would be something relatively simple where you plug in all the different components, and then you have the same functionality, but in a foolproof package. At a later point, you can also choose to directly solder the components onto the board. So then it's a bit more compact. Or you could even choose to have these little components on the circuit board itself. But more information, more in-depth information like this will be, you can find later online. So this will be just a very easy to follow along introduction into transforming a breadboard prototype into a printed circuit board. So this is roughly the presentation or the program for today. There will be a short presentation about printed circuit boards itself, explaining a piece of software called EasyEDA, where you can draw schematics and you can also make a PCB layout. We have 2 short exercises in between, and later we can also have a discussion, or we can help you with any projects or questions that you have. And if you have questions during the presentation, you can either put them in the chat, and some of the people from the Delft Open Hardware community will answer them, or we can also choose to discuss them later at the end. So basically, first, just an introduction on what is a printed circuit board. Basically, a printed circuit board is a piece of glass fiber which has a copper layer often on top and also at the bottom, and sometimes multiple layers in between. And these copper layers can make a electrical connection between different components that you would solder on a printed circuit board. And what you see is that these printed circuit boards are almost in all of the electronics that you see nowadays. So most of the people know the standard green printed circuit boards. Nowadays you have them in all different sizes and colors. And basically what you have is a piece of glass fiber material, and then there is copper, and then there is a screen on top of it to protect the copper layer. This can be on both sides, and also even more fancy ones have it multiple layers in the middle if it's a very complex design. But today we're going to just stick to the 2-layer printed circuit board. And why would you make a printed circuit board? Well, often this helps to bring your project to the next stage. So maybe in the beginning you have a prototype on this breadboard or on a piece of proto board where you can test if the project works as expected. But if you want to take it to the next stage, make it more easily to mass produce, or if you want to integrate it in a certain enclosure, and if you just basically want to make it automated or make it simpler, then you would go to a printed circuit board. And on these printed circuit boards, there's often multiple layers, which makes up the printed circuit board. So from top to bottom, there's first a silk screen. So this is basically the text and the images that are on the printed circuit board. So here you can see, for example, the white text, or here as well the white text with the explanation on what goes where. That is the silk screen on top. Underneath that layer, you can see the red layer. So this is the solder mask, and this basically protects the copper. Underneath there's a copper layer where you route all the traces, and you make basically the wires into a 2D surface. And underneath the copper, there is the glass fiber, and the same stack is also on the bottom. So copper layer, solder mask, and silk screen. And basically what you do is, once you have a circuit board, you place components on them to have it function as you want. Often there's 2 types of components, either SMD components, so these are surface mount components, or through hole components, which basically go through the whole printed circuit board. So in the presentation, there's one item where you see it's just on top, and the other one goes all the way through. If we head on to the overhead camera, you can see, for example, here, some of the pads. Let me see if I can focus. So some of the pads are just on the surface, and that's where you would solder SMD components. And some of the pads, they go all the way through, and these are through hole components. Often in automated manufacturing, you see more and more SMD components because they can either be very small and be placed with a machine. Often hobby projects, they tend to use more through hole components, but also connectors can often be through hole components because they give a little bit more strength, because it's basically soldered on both sides of the board instead of just on one side. So that's basically builds up your printed circuit board. And then there's different ways to manufacture a printed circuit board. So So traditional printed circuit board making is you get a piece of glass fiber which already has the copper plating on it, and then you give it a mask, which you can see on the right top corner, and there you expose it to an acidic solution, and then it eats away the copper where there's no mask, and the copper stays where there is a mask. And then you take off the mask, and then you have basically your printed circuit board. Another option for making a printed circuit board is with milling. So you would also start with a piece of glass fiber and copper on top, and then you would mill away where you don't want to have copper. Both of these are basically how printed circuit boards got started, and what they used to do if they want to make a prototype printed circuit board. If you want to make larger quantities, or basically all the printed circuit boards in consumer electronics, they are made with the first method, but then basically fully automated. So yeah, basically computer and machines, they take all the steps, and yeah, then they can also be automatically populated with the different components and soldered. And in the last few years, this technology has also become a lot more accessible for hobbyists, for makers, to be able to have the printed circuit boards made in an automated fashion. So you would draw it on the computer, send it to have it manufactured, and then a week later you would get the package in with your printed circuit boards that you drew on the computer. So you don't need to fiddle with a CNC machine or an acidic bath and different ways of exposing the mask onto the copper surface. So this made it super convenient and yeah, quite accessible. Also, this workshop will go into this last method where we draw a printed circuit board on the computer, and then at a later point, if you want, you can order the printed circuit board. And in making a printed circuit board, you often see a few very specific steps. So what you would do is you first have an idea of a project, you start a project, and you figure out what components you would need. And you want to make an overview of how these components interact with each other, how they get power, and just get a general idea of the project. Next up would be making a schematic, where you place all of the different components in the schematic, route the wires, just as you would do on a breadboard, to get an understanding of how everything is electrically connected. Next up, you want to transform this into a PCB layout, where you decide what size of the components you should use, how the board should look like. Does it need to fit in a specific enclosure, or does it need to have other properties for the physical outline? And then you can also route where you want the electrical wires to go. And then next up would be generating the Gerbers. These are basically files that you can send to a board house, a manufacturer of printed circuit boards, and they can then use these files to make a printed circuit board for you. And then once you get it, the printed circuit board at your doorstep, you can start soldering in the components, test it. Often there's a mistake, either I have seen it more often that it was my own fault, but sometimes also the PCB manufacturers, they do something weird, or they try to cut corners to make it as cheap as possible. So you see the red box. This is basically what we're gonna focus on today. So we assume that there's already a project and there's already an idea of the schematic. And all we need to do is basically place these components and decide how the printed circuit board should look like. I'm going to show you an example of an air quality sensor, and we can do a simple example of an LED and a buzzer that you could use for a Internet of Things device. But if you have your own project, then please follow along and yeah, feel free to ask questions or to show what you're working on, to share your idea. So with that, I think we can head on over to the HackMD and basically go through the different steps on making a printed circuit board. So now I will just open the HackMD. So this is how the HackMD environment looks like. If you see an error or if you would like to add information, you can always click on this button, start typing, and you can see it directly here. Or if you don't want to log in, you can always make a comment. Yeah, let's see. Okay, we're well on time, so that's very good. Basically, the first part goes into the EasyEDA schematic. So in general, what you want to do is you have components, you have an idea of sort of something that you want to make, and then you want to reach this level where you sort of make a schematic of a project, and you make your route where wires would go. So for that, you can open up EasyEDA, and which I have done in the background. So now you should also be able to see the EasyEDA environment. And here I opened the example of the air quality sensor. And when you see this, this is sort of a technical drawing, a place for putting your components and drawing the electrical connections. But it doesn't have to do anything with the physical alignment of the components. So here you are free to move around components, and it just gives an idea on which pin is connected to what. So for example, here you see a microcontroller. And this microcontroller needs power, which in this case is called VCC. And it has a ground connection. So then you can make sure that the microcontroller is working. And in order to interact with the other components, you want to create connections, just like your on your breadboard prototype. So in order to place these components and to make these connections, you can use either the commonly library or the general library. Commonly library is for components which are very much general purpose. So this would be resistors, capacitors, connectors. So if you press this, it opens up a window, and here you can choose which components to place. So if it starts with an R, then it's a resistor, and you can use the drop-down menu to decide which size of resistor you want to, which physical size the resistor should have. And if it starts with a C, you can choose which type of capacitor you would like to use. On the right side, you see US. On the left side, you see EU. This is just a practical convention. So for example, in the Netherlands, in EU, we use this shape for a resistor, where in the US, they use this icon. So if you want to place a resistor, you would click on this, and then wherever your mouse is, you can place a resistor. You can place basically multiple resistors. When you press escape, then you go out of the resistor, and then you can still move around the components. and you can give them a different value. So if you double click on the 1K, then you can change the value of the resistor. And this is something you can do for all your components. And if you use things other than commonly available components, so something else than a resistor, a capacitor, or a this is basically a header connector, you can use the library. So if I press this, it gives up a pop-up module. And from here, you can search, for example, for LED 5mm. And then it will look for components that have this property. So just now, for the microcontroller, I used a WeMOS D1 Mini. So if you search for this, at the beginning, it will always give you an LCSC suggestion. So this is basically the component supplier that also made this software, and they will always try to sell you their parts. But this is something easy that you can use. In this case, they don't have any of these ones anymore in stock. But it does give you a schematic view and a printed circuit board view. But sometimes people want to use other components that you cannot buy at LCSC or that they find useful for themselves. So you can also head on over to this user contributed item, and there you can find different people suggesting different components. And this way you can, for example, somebody made a item which is a WeMOS D1 Mini shield. So this is something that you could put on top of the WeMOS. So for example, this, you can place it like so. And then you can connect different connectors to this. So if you want to make connections between different items, then what you can do is either make wires, which you can see here, which are the green lines, or you can make a net. And a net is just to keep things very neat and organized. So for example, we want to connect this WeMOS to this CCS 811 board. Basically, what we would need to do is connect the D1 pin, which is the SCL pin, to the same SCL pin here. Normally, how you would do that is run a wire from your start point until your end point. So for that, you can use these tools up here. The first one is a wire. You can also use the shortcut W. And then you would start wherever you want. If you see a dot, that is something where the wire can start. And then from there, you can draw and you can go to SCL, for example, like this. This is how you can do your whole schematic. Please note that here you don't see a dot appear, so they are not connected. Where, for example, here you see this red dot and then they are connected. If I were to make a wire that would start here and then I would press here, then it would give a red dot. But because we go directly from D1 to SCL, then it knows it should be only connected this one to this one and not anything in between. But now, if I want to connect any other component, then I would need to do a wire again from here and then somewhere to the next one. So it can easily get very cluttered. And that's why people really like to use nets, which is this button. And here you can assign a name for something, and everything with the same name will be connected together. So here you can place them anywhere, and you can use a wire to connect it to a specific pin. And now you see, for example, net port 1 and net port 2. And then these two are not connected because they don't have the same name. But now if we connect this to SCL and we connect this to SCL, then the computer knows that these two are connected to each other, and that in the circuit board in the end, these should be connected to each other. And that is basically how you can start to draw your whole schematic. Two tips that I want to give you for which makes it easy to understand a schematic from somebody else is that you often have power coming from the top and going down, and the ground all the way at the bottom. So here you see the microcontroller, you see power entering at the top and ground leaving at the bottom, and then the different connectors. Here you see which of the pins are used in this instance, and you can see that there's crosses at the connectors, the pins that are not used. So for that, there's a cross here, and you can place them wherever you don't want to connect anything. So this is basically how you would start to draw up your schematic. And in the HackMD page, there's also a little exercise that I think can be a lot of fun to do to try and start to understand how EasyEDA works, and to basically draw up a simple schematic. So yeah, I would like to give everybody now at least 10 minutes to see if they can start to draw something, and then this would also make it possible to find errors, or if you find something that is difficult to understand. The idea is that you place these components and then you connect the wires, and in the end it should look something like this. I also have it opened here, and yeah, basically if there are no other questions at the moment, I would say let's get started with this. And then at 1:15, see if everybody was able to recreate something like this. So the next step would be it's good to get an understanding if the other people also managed to follow along, if they have any challenges at the moment. And I think if it's silent, then I'm assuming that it's understandable, so that's good.
Got it.
Okay, nice. I see some thumbs up. No challenge here. Okay, that's good. So then I want to show one more thing before we can proceed to the next step. And before we turn this schematic into a printed circuit board, we will have a short break. But before that, there's one thing I would like to show. So as soon as you have this schematic finished, what you can do is save it. That's always good. And then what we want to do is ultimately press this button, and then it will convert the schematic to PCB.
Jerry, you're not sharing your screen right now.
Oh, I'm so sorry. Thank you. So now you should be able to see my screen. And what I was explaining is that as soon as you have your schematic complete, you're happy about the placement, what you can do is, this is just for yourself, something personal, but you can add either text or a box to make something a bit easier to understand. So for example, this is and this will not show up in your printed circuit board itself, but it's just for others to understand what's going on. And then once you're happy with the full schematic, then it's good to save it. It will give you a small pop-up on the bottom right corner. And then there is this button here at the top, convert schematic to PCB. And basically that will allow you to make a PCB from this schematic. If there is a problem, then it will also showcase it here. So for example, now we made a change. One of the pins is not connected. So let's change it so it's updated. And then we export it. And then there it says there are some unfinished nets. Do you want to check the nets first? So this is basically a check to see if the schematic is correct. So here you would say yes. And then on the left-hand side, you see that this gives an error or like an exclamation mark, and it says an incomplete net here at the bottom. And this shows you that there's a problem to fix at the WeMOS component, so that's here, and then at the 5-volt pin, so that's here. So then if we do place the X here and we save it, and then we can do it again, and if it doesn't give any errors in the net, it will directly go into the PCB. And if it does, it will show you on the left-hand side again. So that's basically the complete part for the schematic. And from there, we can go into the PCB, the physical PCB design. And for that, before we go into that, I would like to suggest to have a short break. So maybe 10 minutes, we can stand up a bit, take a break, and then at 15:30 we start again. I show you all the details that go into making the physical layout of the PCB and what to think about. And then there's also another short exercise, and then we can continue from there on. So yeah, let's meet again in 10 minutes. Okay, cool. Yeah, oh, this is great. Okay. Yeah, so now we can continue to the next part, and that's basically transforming the schematic into the printed circuit board. And with this, yeah, it's basically all about placing the components at the place where you want, and also routing the wires. So for this, I will also share my screen. Let me see, sharing. Okay, so here you can see an example of a drawing of a printed circuit board. So once you have your schematic as you like it, what you would do is convert it into a printed circuit board. In the meantime, the wind has also reached Delft, and there's a tree right in front of my window. It's still holding on, but it seems to go quite, it's leaning quite a bit. So maybe this will, this meeting or like this workshop will have a spectacular ending. Then it's at least captured on the recording. But for now, let's focus on the printed circuit board itself. So as soon as you click convert to printed circuit boards, it will give you this pop-up, new PCB. Here you can choose the units, the amount of copper layers. So if you want to do a lot more complicated printed circuit boards, then you can choose more than 2 copper layers. So in general, most of the projects can be done on 2 layers. And that's basically the top and the bottom. And if not, then they will place different copper layers in between the glass fiber. Here you can choose the board layout. So for example, a rectangular, circular, rounded rectangular, or even a custom one. And in this case, you would import a DXF file from your 3D modeling software. For now, we're going to keep it simple. We can do rectangular or round rectangular. And I always find it nice to start at zeros and then, for example, have a width of 30 and a height of 35, and then a rounded corner of 2 millimeters. So if we hit apply, then this purple shape will pop up, and this is basically the outline of our printed circuit board. So in here, if you hover over the layers and objects, then it will give you it will show you which different layers there are. So here you can see in red the top layer, blue the bottom layer, top silk screen, bottom silk screen, and for example, the pink is the board outline. And basically from here, what you want to do is place the components however you want on the board. So you can grab a component. So this was the WeMOS shield that we chose. And you can place them, for example, here. And you can place this one and this one. So now it's outside of the board. And then here it will be inside of the board. But this is kind of crowded because all of the components are on the top layer. And it would also result in stacking components on top of each other, which is not ideal. So in this case, we want to place the buzzer at the other side of the board. And how to do that is basically by clicking this component, and then on the right it says top layer, so you can choose bottom layer. And the same we can do for the LED. And now you can see they turned green, which means that the silk screen is on the bottom, and the LED is now also at the bottom. And if you want to get a bit more of a physical understanding of this, what I like to do is go to the 3D viewer. So let's first save the project. So then it gives up a pop-up that it's saved. And we can go to 3D. And here you can see the board itself in blue. And you can see where the WeMOS D1 would be placed. And then here on the other side, you can see the LED and the buzzer. So this helps to give you a understanding of the PCB itself. It doesn't auto-update, so always once you're finished with viewing the 3D model, you can close this and go back to here, make changes, and then press the 3D model again. And then basically here, the goal is to place the components however you want and connect all the electronic wires. There are 2 ways to go about this. One is routing it by hand, so choosing where the wires, the paths should go, or having the computer figure this out. And if you look carefully, you can see these thin blue lines, and these are the red lines. So you can turn them on and off. And these basically indicate which component should be connected to what. So if I now, for example, start with a track, I can choose the size of this track. So the routing width, I can make that 0.4, for example. And then I can start here, and then everything that's connected to this will then highlight in white. So I can go, for example, to, oh, I want to go to this path, but it doesn't stick to it. And that is because I am currently drawing on the top layer where the component itself is on the bottom layer. So I close this, I select the bottom layer. This also makes it more bright. And then I can go from one to the other. And for example, from here to the ground where it needs to go. And now I already made all of the ground connections. And this is how you can do all of the routing. There's a few things to keep in mind. One is that often it's good to use, if you need to make a corner, that you do a 45-degree corner. So here you see the trace, and this could be fully a 90-degree angle trace, but that's more difficult for manufacturing. So you're better off doing this 45-degree angle. There is also this thing about data transfer, but that's very much more in depth. So for now, just keep in mind, try to make 45 degrees angles. That makes it easy for manufacturing. And then another approach which you could try is auto routing, where you let the computer decide how to place this. If you ever want to start over with routing, then you can press this Unroute All button, and we can see if we can do a auto routing. Sometimes there can be many people routing at once, so then it will give an error that there were too many requests. But in this case, it says connections, attempted 9, completed 9, 100% success rate, and 0 of them failed. If it's too complex, if your board is too small, then it will give an error. But we can press OK in this instance. And then you can see that at the bottom, it placed a few wires, and at the top. And you can see if you're happy with the results. So in this case, I do have to say that here the wire, yeah, it goes to the outside and then around this 5-volt. But maybe I would like it a bit more further from the 5-volt pin, just to make sure that it's easy to manufacture. And this also prevents any challenges this prevents any challenges if you're soldering and you, for example, scrape accidentally some of the solder mask off. So that's basically a very quick start into making the physical layout of the printed circuit board. And then it's also good to think about how will this printed circuit board be used. So maybe there you want to place a mounting hole. So for that, there's this button hole. And then you can, for example, place some holes so you can screw it down onto something. If you then select this, you can change the size of this hole and the exact location of this hole. So you also know if you want to make a 3D print, for example, you know where it's placed. But now if we save this, and if we go back into the 3D viewer, then here you see that it also made the holes into the printed circuit board. And if we flip it around, it is, I must say, slightly difficult to see, but you can see the traces. So maybe we make this visible, but we make the paste. And the solder mask invisible. So if we hide the bottom solder mask, you can also see how it will be routed, basically. So here you can see how the traces would be in the printed circuit board at the end. We can close this. We can save this. And yeah, that's a first introduction into making the printed circuit board. If you are using a lot of power, then it's important to make sure that this power can be delivered. So you can change the width of the lines. So for example, here we can say 0.5 millimeter, so that it can deliver more energy without losing it on the thin side of the track. And for this, you can also set up design rules, and that makes it possible to say that every line that is using a lot of power needs to be at least this thickness. You can also calculate what this thickness should be, and for that there are online track width calculators where you say it's this much voltage going through, this much amps, and what thickness of the trace should it be. And based on that, you can size it accordingly. In this case, we are not consuming a lot of power, so we can keep it fairly thin. But it's good to remember that in the end, the board starts out as fully copper, and it etches away places where you don't want to have copper. So it's okay to be generous with the thickness of the tracks, basically. So there was a question from the chat: where did you round the corners of the board? So in order to make the corners of the board round, what you can do is go to Tools, set the board outline, and then you can say rectangular, circular, round rectangular. If I make it rectangular and I click Apply, then you see a square printed circuit board. If we set the board outline to round rectangular, we can also define the radius. So this is how I made it round. But I could also file import a DXF, and then I can have a whatever shape I want, basically, and then set that as the board outline. So basically from here, I would like to go into the next exercise where we try to recreate this. So basically, if you're in your schematic, you can go to convert to schematic to PCB, and then it should make you sort of this layout. So let me know if all of that works. And I think we can take around 10 minutes to see if we can recreate this. If everybody already finishes early, then we can even go a bit further and see what else we can do. So for now, I will stop sharing my screen. The exact exercise is in the HackMD page. So there you can find details, and then feel free to post your questions in the chat. And if somebody wants to share his screen so that we can follow along, please feel free. And if not, that's also okay. Cool. Well, this is going super well, Angela. So it's great to see that you already have converted it to the printed circuit board. I was wondering, did you use the auto route feature, or you route it yourself?
I did it by myself, so it's not auto. Just and also only on the one side. Everything I squeezed in between LED. Maybe it's not the best way because it shouldn't go that because it's super small. But yeah, see, I squeezed this thing here, so it might work.
Yeah, I would say normally I don't see a problem for routing underneath components. Sometimes it can be a bit challenging if you want to, at a later point, make an adjustment to the board and maybe you want to disconnect this wire, then you first need to remove the component before you can reach the trace. But yeah, this looks great. It's also nice to have 4 of the mounting corners in each side. So that makes it possible to really screw it down onto something.
Jerry, I had a question about the SMD versus through whole component. Because you have that placeholder for the component to be mounted, and then the bus is on top of it and going through the circuit. Yeah. And I was wondering if there is a conflict there of components because there's or because I see that the buzzer goes through,
Yeah, so that's correct. Basically, yeah. Let me head on over to the overhead camera and see if I can share this. So share. Okay. Let me zoom out a bit and adjust the camera. Yeah. So in general, you're correct. Basically, we're placing this buzzer, for example, right on top of the mounting for the WMOS, and in a sense, you're right that it will interfere with each other. The only upside is that this WMOS development board, if you were to solder it down onto the board, then there's still a bit of clearance where these components of this board don't touch this printed circuit board. And you're also, once you have soldered down the buzzer, you should clip off the ends that still protrude. So you make sure that it's as flat as possible and that you can have components on the other side. But if you're not sure about if it will fit together, then I can always recommend to make just a little bit bigger printed circuit board and place the components next to each other or just on one side, for example, because then you're sure that they don't interfere with each other. So here we can say board outline. We can make it, for example, 55. So now it's a bit longer. We do want to make sure to unroute it. So now it's possible to place the buzzer outside of the other component, and then we can even place it back on top of the printed circuit board. So, for example, now we put them back on top, and we can save this. If we now go into the 3D viewer, you would see that the PCB is a bit longer. You have them on one place and you can route it again. This is something that you can do to your liking, and that is why it's also always handy to already have either a breadboard prototype or already have the components in-house, so you can measure if it will actually fit, if there's interference, and yeah, these things can help a lot. Okay. And let me see. Yeah, so I think from this point on, we can already slowly continue toward the end of the workshop. So a difference that you can see between this printed circuit board and the printed circuit board that I showed earlier, for example, this, is that there is a big red square, rounded square here. And that is basically a ground plane. So often this helps if you to prevent any interference from other components and to make sure that there's no, you don't get weird electromagnetic resonance. So let me just take this out. So this is basically the same as we've seen before. So we have the different components laid out however we...
Jerry, we again can't see the screen.
Cannot see my screen?
Yeah.
Uh-oh, again. Okay, let me try this
We
one
were
more time.
all too busy making our own PCBs.
Yeah, sorry. Okay. So let me go back a few steps. So a big difference between what you see here and what you see in this printed circuit board, if it rebuilds, is that there is a big red rounded rectangle on the board. And that basically means that there's still all of the copper area. And this is basically one big ground plane so that you can, it prevents any capacitance and electromagnetic interference. So that is something that you can easily add. And I'm gonna quickly show you how this is done. So basically you have the same setup where you have the different components, you route it however you want, and something that you can then skip is you don't need to route the ground wire yet, because that will be connected through the ground plane. So you can use this this solid area, and from there you you can use this copper area. You can say that you want to connect it to ground, and then you can draw a square where the copper area to be, and then it basically fills every area where there's still room with a copper area that is then connected to all of the ground pads. And you can do the same for the bottom layer. So ground, copper area connected to the ground, making a square. And then it fills in all of the area with a big ground plane. With this, you can also choose how far it should be from the side. So now it's quite close. You could also say that it should be at least 1 millimeter from the outside of the board, or 0.5 millimeter, for example, from all of the other traces. So then you see that there is a bigger distance here. And with that, basically your board is done. You can give it a final check in the 3D viewer to see if it's actually what you like. And then from there on, if we go back to the printed circuit board, you have these 3 icons, and then the middle one is for PCB fabrication file, Gerber. So you can press this, and then it says, would you like to do the design rule checking, DRC, before generating the Gerber file? Usually it's good to check this, and then it checks if your printed circuit board is up to the standards that you made. So if there is enough clearance, if the tracks are thick enough, and basically once you have reached this pop-up screen, you can either click here to generate the Gerber, to download it, or if you wanna be even quicker, you can click the one-click order. It opens a browser. It should open the JLC PCB website. And let's see, now that I've signed in. Where it uploads your Gerber. You can always do this at a later point on glcpcb.com. And basically from here, you get a preview of the printed circuit board that you just drew. And you can choose, for example, what color the circuit board should have. This will also have an influence on the price often. And what thickness of copper, and whether you want to use or not use the order number. So often there's a little number somewhere in the corner, so they know which board it is. The top parts are always already filled in from the Gerber files. So it's a glass fiber board. It has 2 layers. It has 40 by 60 millimeter dimension. And here you can choose the quantity. So yeah, you can choose, for example, 5 boards, 10 boards. And then here you can see that 10 boards will set you back $5, and it will also cost you for $3.90 for shipping. This is sort of normal shipping, so it takes 2 to 4 weeks before it arrives. You can also do express shipping. Then it's a lot more expensive, but usually it's back. You receive the boards in a week or something. So this can be really quickly if you want to prototype fast. And that's basically from there on you can save to cart and order it. So what you guys have been building in short is basically a Internet of Things buzzer or indicator light. So what you could do is place a WeMOS board on top of this and program it so that, for example, if your favorite YouTuber goes live, that it will bleep and it will make a light. Or if we maybe have a new event, then you can also program it that it will give you a notification. So that's in very short the things you can do with a printed circuit board. And usually this can really make it look nice. You can integrate it in maybe, for example, a 3D print. And it also makes it easy for other people to replicate your project, because they can just download the Gerber files and then order the printed circuit boards. And by now you see tons of people sharing their files online, so you can build basically their same projects. So yeah, that's basically taking it beyond the drawing the printed circuit board and ordering it. Let me see if there's any questions in the meantime in the chat. Seems good. Yeah, so you can always check on if you press the generate Gerber files, if it allows you to export it, and if the board seems correct. So from there you can you can order the PCB or share it with other people who can recreate it. On the HackMD page, we have a sort of third and final exercise. We didn't know how much time this exactly would cost, so you can also do it as a homework. You can choose to do it at a later point, or you can choose to do it now if you want. But what you can do is, play around with these PCBs, find an application where you find it useful, and really try to imagine how this PCB would be integrated into something bigger. What requirements these what requirements come from integrating it into something bigger, and also, for example, if you want to make it battery powered, then you probably need some extra components, and how does this influence your printed circuit board? Lastly, we have some further readings on the HackMD page. So there's a lot more YouTube videos about how to make a printed circuit board. For now, we just showed you EasyEDA software. This is a quite entry-level, easy-to-use software to make a printed circuit board. But there are also a lot more advanced tools for making printed circuit boards, which are more often used in the industry. So this is, for example, KiCad, which is an open source program. You have Eagle, which is part of Autodesk. And I think you have Altium Designer, where you can also make printed circuit boards. Often they all have a function to export Gerber files, so that's good. That makes it a bit interchangeable. And you can choose whatever you like for software to build these printed circuit boards. I don't know if there's any more questions specifically for the printed circuit boards and the exercises.
I think what I wanted to say that I found this link with very simple exercises to practice. They have very simple setups of sensors and things like that. So it's interesting because I think with this to practice doing simple things and then make it more complicated things are always useful, you know. So the third exercise is meant to be challenging with more components and things like that. And those other exercises are, it's like to build from simple to more complicated, complex.
Yeah, that seems great. So I think we can add it to the HackMD page, so also people can look at it at a later point. And then last up, I would like to quickly go back into the presentation, because there's one more thing that I would like to show to you. Slideshow. There's also some people really putting a lot of effort and a lot of work into these printed circuit boards, and with that you can make just amazing printed circuit boards. So there's people who do artwork in both the visual style but also the mechanical usage of a printed circuit board. So here you see some of them with visual examples where they really try to route it in a specific way or use the different layers in a PCB. So for example, here you can see some of the exposed copper, you can see some of the silk screen, and you can see some of the solder mask. And with that, you can really play with different layers on the PCB to get a different effect. And you have people who really use printed circuit boards to make objects. So they solder them at the right angles, or they make connectors, so they plug different circuit boards into each other. So that's always cool to keep in mind, and you can put a lot useful information, but also a lot of beautiful information into the printed circuit board. And there's also some design rules that can help you design a board and that make it easier to manufacture. So different manufacturers have different requirements. Some are more precise, some are more easy to manufacture. So these two links, which are also in the HackMD, give you an idea on what specific rules a PCB manufacturer can have. And yeah, I would say feel free to add more questions or discuss more onto the into the HackMD page. And yeah, with that, I think it's nice to explain also a bit more about ourselves. So for all the people who are new here today, we are Delft Open Hardware. We are part of the Open Science program, and we basically just want to help everyone to be able to make open source projects. So this can be either by mentoring projects from students or researchers, to giving workshops like, for example, this one, where you can really get some hands-on knowledge about a certain topic, but also, yeah, supporting alumni to build and grow their project and help them with making the correct documentation so other people can replicate it. And basically, if people have questions about different licenses or what would be the best way to share a project or to build a certain type of project so people can replicate it, that's basically what we do. So last November, I was hired as a research hardware engineer to really support all different projects at the TU Delft, but we're also open to people from outside the TU Delft. Yeah, everybody basically who is interested in open hardware. We have a weekly lunch meeting on Friday from 12:30 to 1:30, where everybody can join in, tell about the projects that they're working on, and show ask questions if they want to know how other people would go about either sharing a project or building it. And yeah, basically we just hang out. If it's not too windy outside, we have an occasional barbecue in Delft. So that's a quick background in Delft Open Hardware. Just a bunch of people who really like working on hacking on projects. And I think Angela would also like to add something. I already see the mic coming in.
No, I just put the mic there.
Oh, okay.
Thank
cool.
you. Just
Yeah.
this.
Yeah.
Like bravo.
Cool. Oh, wow.
Thank you.
Yeah. So also Rob or Abrihob, I'm sorry if I mispronounce your name. If you guys want to share anything that you're working on, or if you have any other questions, if you want to introduce yourself, then feel free to do so. Yeah, some of us are working at the TU, some of them are used to work at the TU. Some of them, yeah, quite a lot of us were students at the TU Delft. So yeah, quite a diverse background, I would say. And yeah, other than that, I don't know if Angela, I think you were also working on a project where you replicated a printed circuit board from somebody else, right?
Yes, that's true. Let me just put the headphones on here. Yeah, I can show you. I have it on here. So I used like a ready done thing. So PCB was made by someone on a web, and I got boards from the same place, and then I built this is air quality sensor. I'll try to put it on camera, or just to put it wait. It's easier to use a camera and move the camera.
Oh wow.
Oh yeah. So this is how it looks like. It has the sensors, different sensors for the air. This is CO2 sensor, ozone sensor here. Let me see if I can put some light. If it's too much, maybe it's too much shadow now. Yeah, but
and Arduino Micro.
Yes, that's super small one, and there's touchscreen here with a which you can which has a card by itself, and also CPU. So it's like a simple link. So you just send the data there, and you put the actual code inside of the screen as well, and it can work as a separate. So it's just the data in and out, and this is other sensor here on the side. So it has 1, 2, 3, 4, 5 sensors for the air, quality.
Cool.
And I can share a link if someone wants to build it. And I'm also willing to share because I bought. Usually when you buy a boards, you don't buy one, you buy 10. So I have 9 more, and if anyone wants to build the same thing, I have it here. So I will just share. And I also have some parts for this, so I can also share that as well.
Cool. Yeah, I think it will be great to put it in the HackMD so people can see what the project is about, and then we can always, through Telegram or something, get in contact with each other. Also, if you want to work on a project and you need components, then sometimes Delft Open Hardware has some components, or people have some personal components. So always feel free to reach out, and then often we can help you with the development of a project. So
I just shared in the chat the links on YouTube, how it looks like when it's kind of fully done, and also link how you can make it. And there you can also find the files for a PCB and everything, and like a code, and you can also change code or like a look. And
okay, that's great. I'm adding it to the HackMD at the moment. So that's really nice. So I was wondering, did somebody join for a specific project, or was it just a more general learning about the printed circuit boards by itself?
For me, it was the latter. Just learn how to make it.
Yeah, cool. General learning, cool.
Yeah, even for me, it was general learning, not for any specific project.
Okay, that's good to know. So feel free to play around a bit more with the EasyEDA. I'm planning to order some printed circuit boards somewhere in the coming month. So if people have drawn something, if they want to order something, we can also combine some orders. So then you don't have to pay any shipping, and we can make sure that they will reach you, or you can pick them up at TU Delft. And that can really lower the price. So then for I think €2 or something, you can already have 5 of your own printed circuit boards. So, and personally, this was like the first printed circuit board that I ever made, and already it didn't work at all as I expected it, as I hoped. The traces were way too thin to convert all the power, because there were a lot of LEDs. But just having a green piece of glass fiber with your name on it, that's already like so cool. So I can highly recommend just playing around and and yeah, joining the group order, because it looks cool.
You can like it always takes some time, and you need to try and make it and burn and go back and forth. The heaviest part is to make a PCBs for the radio things, because you really need to take care how long it will be on board and everything. So it might never work, you know, as you think, and you know, but yeah, true.
Yeah. So that's something that we didn't discuss. This was very entry-level printed circuit board making, but you're right, with very high quality processor, high bandwidth, and also with radios, it's a very exact. Let me see if I can get the the webcam back on. But then you, for example, the way how this is the antenna of the Wi-Fi module, and this is designed in a very specific way so that it can have the right connection with your router. So these are very specific, and sometimes on a Raspberry Pi, for example, you can see some wiggly traces. Let me see if I can get one. But then you really go in depth into the printed circuit board making. So here you see a very relatively complex printed circuit board. Zoom in a bit. And yeah, you see very thin traces, because there needs to be a lot of traces. But also, yeah, what you can see, for example, here in between the silver part and the black part, is that there are some squiggly lines. And these lines, they made deliberately a specific length, because otherwise it would interfere or it would have a wrong readout. So yeah, it can become very complex, but that's only if you make these kind of printed circuit boards. So yeah, now I would say in the beginning, let's try to keep it as simple as possible. Nice thick traces, true hole components, and then from there you can go further and further, basically. So if you have a more complex printed circuit board, you can also split it up into multiple sheets to give a bit clearer explanation of what is going on. And yeah, then in the end, you just have a little bit more complex printed circuit board with more wires routed and more, yeah, often a bigger printed circuit board and more tricks. But the simpler you can keep it, the better. So yeah, just starting with something like this is just a really nice introduction, I would say. Then I think this wraps it up mostly for the workshop itself. We are actually quite on time, so that's nice. It's early weekend then, maybe. If people still have questions at a later point, you can always join our Telegram group or send us an email, or join the lunch meetings every Friday. So yeah, no worries if there's something you don't understand. And with that, I think I would like to end this workshop. So thanks for joining, everybody, and yeah, hope to see you again in the next workshop. I think the plan is to have a seminar on the 25th of March, if I'm correct, Jose.
Yeah.
Yeah, so this will most likely be a talk by a person telling about either a project that they made open source or something else that they're working on. And then the month after that, there's going to be a hands-on workshop again. Hopefully this time at the campus and actually building something, but you never know. So yeah, hope to see you again next month, the month after, or at any of our lunch meetings.
Thank you, Jerry.
See you.
Thank you. Ciao. Ciao.